All right, this is the video lesson for Thursday, January 28th. You have your bell work right there. So I'm gonna give you time to do that, and then we're going to talk about the production possibilities curve. So go ahead and pause the video to do that, and then now we're talking about the production possibilities curve. So the production possibilities curve is a graph that shows the combination of goods and or services an economy can produce when all resources are fully employed. So this is going to be a visual representation of efficiency. This is going to be how much can we do if we are using all of our resources efficiency and every resource is being used fully. So here's what that graph looks like. This is the production possibilities curve. So in this hypothetical mythical economy, we can make two things. We can make cars over here, and we make clothing down here. So as we make cars and clothing, we have trade-offs to make. Notice if we make 0 items of clothing here, we can make 80 cars. So this line, this red line right here, represents full and maximum employment and full and maximum use of resources. So as a society, we can choose to be anywhere on or anywhere inside this line. So let's say we make 0 items of clothing. That's the x-axis, so 0 on the x-axis. We can be up here at 80 cars on the y-axis. Now, as we make more items of clothing, to 100, and then to 200, and then to 300, as we use our resources to make more clothing, we are going to decrease on our y-axis, which is our cars. So as we increase on our x-axis, moving from left to right, we're going to decrease on our y-axis, moving from top to bottom. So we can have full use of our resources at 80 cars and 0 items of clothing. And then we can change our resources to make 70 cars and 300 items of clothing. Or if we move from 300 to 400 items of clothing, we go way down here to point B, and that would cost us 40 cars. So one thing we talk about is opportunity cost. What is the opportunity cost of going from 300 to 400 cars, 300 to 400 items of clothing? Well, that opportunity cost is going to be 7 cars, or from 70 to 40 cars here, so that's 30 cars to go that extra 100 items of clothing. Now, let's say that we move from here at point B to point C. Now we're making even more clothing. The maximum amount of clothing we can make is 415 units of clothing. That's represented by point C. And that's if we only make clothing and not cars. We have 0 cars, 415 items of clothing. That is point C. So we have trade-offs. As we make more clothing, we make less cars. And if we were to go from point C backwards this way, then as we want to make more cars, now we can make less clothing. So really, based on this graph, the best points to be would be at point A or point B, because the opportunity cost of moving from 400 items of clothing to 415 items of clothing is 40 cars, right? But from here, the opportunity cost from going from 0 item of clothing to 300 items of clothing is only 10 cars. Okay, so it would make more sense to be at point A or point B or any point in between. Now, can we get to point E? Well, point E is 40 cars and 300 items of clothing. Yes, we can get to point E, but if we do so, we are being inefficient. Point E is inefficiency. Okay, so if we're on point E, that means that we're producing 40 cars. If we're producing 40 cars, we should be able to produce 400 units of clothing. Or if we're producing 300 units of clothing, we should be able to produce 70 cars. So if this is a society, if this is a country, we as a country are going to make these decisions and these trade-offs. We're going to make more or less of one item, and we're going to be somewhere along this production possibilities curve. Hopefully, we can be as close to the curve as possible. If we have a company, it's the same sort of thing. If we were Apple Corporation, we could use the resources that we have to produce new iPhones. Okay, so maybe iPhones is going to be the x-axis, maybe iPads or iMacs is going to be the y-axis. We'll say iPads. So as we use our resources to produce more iPhones, now we can produce less iPads. If we want to move up the y-axis, it's going to be to move if we want to move up the y-axis, it's going to require us to move down the x-axis and make us produce less iPhones, because the iPhones was the x-axis. So it's really not a complicated map, or not a complicated graph. You're not going to have to plot points or anything like that, but just look at this and realize that everything on the line is efficient use of resources, is maximum use of resources. All the resources are properly employed on the line. Inside the line is going to represent inefficiency. But what about point D? Point D out here, where if we're at 70 cars and 400 units of clothing, that's outside of the curve. Well, we can't get to point D. We can't do point D, because if we're making 70 cars right here, then that's going to be at point A, and that's only going to allow us to make 300 units of clothing. And if we're making 400 units of clothing, we have to sacrifice down to 40 cars, right? So we can't get to point D. So what does point D represent? Point D represents a point in the future. We would love to be able to get to point D, but with our current resources and with our current processes and technologies, we just simply cannot get to point D. We're going to need innovation. So point D represents the future, and point D also represents innovation. Point D represents us doing something better in the future. Okay? Point D represents us learning how to maximally use our resources, or by getting more resources. Either thing we cannot do right now. So that is going to be point D, which is in the future. This graph shows the economies, and the economies of the United States and Canada in terms of GDP. And I just show you this to show you that point D is going to be attainable, right? If we looked at this graph in 2000, right here for the United States in 2000, looks like we were maybe $14 trillion of GDP in 2000. So we're at 14 trillion, and then it goes up. So in the year 2000, this would have been this line that we would have been able to get to. But by 2010, now all of a sudden we're out here at a point that otherwise would have been unattainable in 2010. In 2010, if you say, why can't we just have $17 trillion in GDP? The answer is, well, we can't have $17 trillion in GDP because, well, that's in the future. Okay, so now in 2010, maybe we can get closer to, or I guess 2016, we get closer to $17 trillion. So as we grow the economy and as we grow our efficiency, we're able to get to over to that point, which is going to be D, which is in the future, which is economic growth. Okay. And how do we get to economic growth? Well, we increase our productivity. So I have 4 words for you here that you need to get into your notes. The first is economic growth. This occurs when a nation's total output of goods and services increases over time. Here's a visual representation of economic growth. You can see way back in 1900, the GDP in terms of trillions looks like it's barely over 1 trillion. And over the course of 100 years, it's up to 14 trillion. So that number is growing rapidly. That is economic growth, when you increase the nation's total output of goods and services over time. Next is productivity. Everyone benefits when scarce resources are used efficiently. That means that we are on this line. If we are being productive, we are on this line. We are not inside this line. Maybe we're a little bit inside this line because we're trying to get as close to being maximally productive as possible. Okay. One of the ways we do that is with division of labor. This takes place when work is arranged that individual workers do fewer tasks than before. So if I am a factory worker, instead of me as a factory worker, maybe I work for the GM factory in Detroit, Michigan. Maybe instead of me having to build an entire engine myself, maybe I have one part of the engine building process. I'm going to put one specific item in one specific place, and then I'm going to pass it down to the next person on the assembly line. That is going to be division of labor. That is, you handle this and I will handle that. And as as time goes on, it's going to make it much easier. You can think about it as division of labor, being that, in a school, there's one teacher who teaches economics and another teacher who teaches math, right? We are dividing the labor instead of you just coming to me and me teaching you all of your subjects. And part of the reason that works is because of specialization. Specialization takes place when factors of production perform tasks that they can do relatively more efficiently than others. In your career, you're going to have a specialization. You're going to do something that makes you better and more specialized in that role than the general human. So the reason that I don't teach your math class and your economics class and your science class and your PE class and all that, the reason I don't do that is because I am specialized. I specialize in teaching government and economics, where your science teacher specializes in teaching science. I couldn't teach you the science. I couldn't teach you the math because I didn't specialize in that. Because there's a certain amount of knowledge that you need in order to teach these subjects at this level, and I just can't specialize in everything, right? So you don't have one person build your entire house. You have one person who's an architect, and one person who's a contractor, one person who's a carpenter, and one person who's maybe a laborer, or maybe several people who are labor. One person who specializes on the roof, one person who specializes on the plumbing, and you have all these different specializations because of how intricate and detailed those skills are. And when you have individuals who get more and more specialized and they get better and better at doing one specific task, that is going to lead to efficiency. And it's going to allow us to even more rapidly grow the economy and even more efficiently reach for this point D, which is in the future. Okay, so that is it for today. Hope you have a great day.